So yesterday we talked about polynomials and we talked about how can we expand polynomials, right? And when we expanded polynomials, for example, if you had plus 1 times 2x minus 3, what did we have to do to expand? We had to multiply, right? What did we use? What was the acronym that we used yesterday for it? No? It's FOIL. Remember the FOIL, right? So where we had to multiply using the distributive property, so multiply this by, right? Which is going to be 2x squared, because x times x is x squared. Yeah? Then you multiply the outer terms, right? So x times negative 3, that's negative 3x. And then the second term is multiplied by both terms in the other bracket. So 1 times 2x is 2x. And then 1 times negative 3 is negative 3. So you see that each term multiplies both terms in the bracket after it. You guys are okay with that? All right. And now we ended up with collecting like terms. So my like terms are these two terms because they both have the same letter x and the same exponent, which is 1. So basically that's going to be 2x squared minus 1x minus 3. And the reason why this is minus 1x because you have negative 3x plus 2x, so that gives you minus 1. Are we okay with that? First drawer. Okay, so this is what we did yesterday. It's called expanding. Okay, so what we're going to do today, we're going to do the opposite of expanding. We're going to do factoring. Okay, do you guys remember what happened when we had the scenario of a monomial? So let's say 3 multiplied by 2x plus 5. What did we have to do? So you do the distributive property, that's right. So you multiply the 3 by the first term, which gives you 6x, and the 3 times the 5, which gives you the 15. Remember that? That's called the distributive property. So today we're going to move backward. Okay? Today we're going to go from this format to this format. Okay? And then the next day, we're going to do from this format to this format. Okay? So we're going to do the backward steps. Okay? So let's look at the greatest common factor. Okay? So a factor, what does that mean? What's the word factor mean? It's a number or a letter that you can divide both terms or all terms by. Okay? So if I want to take, for example, this right here, which is 6x plus 15. What can I divide both terms, the 6x and the 15, by? Can I divide them both by 3? Yes? Yes. Because 6 is divisible by 3 and 15 is divisible by 3. Yeah? So that means my greatest common factor for this is 3. Okay? And then that means I can factor out of 3 of this and then divide each term by 3. So if I divide this by 3, I will end up with 2x because 6 divided by 3 is 2. And then if I divide 15 by 3, I end up with 5. Is that the same thing as what I started with right here? Yes. So you see how I was able to go from here to here by taking out a greatest common factor. Okay? So you're going to have to look at a number that you can multiply both or all terms by. Okay? So let's look at the actual lesson. So when factoring, it's always important to factor out the greatest common factor first. So you're going to try to factor out the largest number and largest degree of exponents for each common variable from each term in the exponent. So here's what we're going to look at. So it's not only the numbers, but also the letters. Okay? So let's look at this. What is the greatest common factor of the following expression? 8x squared minus 2x. So how many terms do you have here? I have 2 terms. Yes? 8x squared and a 2x. Now, what is the greatest common number that I can divide both 8 and 2 by? 2. Good. So my greatest common factor so far, I know it's going to be 2, because I can divide 8 by 2, and I can divide 2 by 2. Do you have a common letter between both terms? What is it? X. Now, x has either x squared or x to the power of 1. You're going to have to take the x to the power of 1, because otherwise you won't be able to divide this properly. Okay? So you always look at the one with the lowest exponent, okay, the letter that has the lowest exponent, and that's going to be the greatest common factor. Okay? So my greatest common factor is going to be 2x. Okay? So when I do that, how do I factor this? So here's what I do. I write it like this. Equals. I put my greatest common factor outside. I open the bracket. And I divide each term by my greatest common factor. Okay? So you write the greatest common factor outside. And then you open bracket, term, and you divide it by the GCF, plus or minus whatever you have here. And then you do the term and divide it by the greatest common factor. Okay? Now, let's simplify. The greatest common factor stays outside. What's 8 divided by 2? 4. And then what's x squared divided by x? X. Okay? What happens here is the x squared basically is x times x, and then you're dividing by x, yes? So this cancels this. You're left with an x. Are we okay with that? Jessica? All right. And then what's 2x divided by 2x? -1. Okay? Anything divided by itself is 1. Okay? So what I have here, I have the GCF, and then what we call here, I call them the leftovers. Okay? So it's always going to be your GCF, and in the brackets, you're going to have your leftovers, whatever leftovers. Okay? Okay, so example number 2 says factor by factoring out the GCF, 6y cubed minus 24y squared. What number can you divide both terms by? Can't you divide them both? Can you divide 6 by 4? I can divide 6 by 6, yes? I can divide 24 by 6. That gives me 4, right? This is where you kind of need your multiplication table, okay? Good. So 6 is my greatest common factor. Is there any common letter? Y. And what would be my exponent that I'm going to take out? 2, because 2 is the lowest exponent of both of them. Okay? So now my greatest common factor is 6, y2, because the square is the lowest exponent. Are we okay with that? It would be y squared. What do you mean 2? My number? 2 would not be your greatest. It will be a factor, but not your greatest. Okay? So what are your factors of 6? Your factors of 6 are 2, 3, and 6. Yes? Your factors of 24. So what can you divide 24 by? You can divide it by 2. You can divide it by 4. You can divide it by 6. Right? You can divide it by 12. You can divide it by 3 and by 8. Right? So 2 is a common factor, but it's not the greatest because 6 is the greatest one of them. Okay? That's why it's by 6. It's it's opposite than the lowest common multiple. So if I take, so just don't worry about all this writing. So I'm going to write my GCF right here, and then I'm going to open my brackets, and I'm going to take each term and divide it by my GCF. That's a 6. Okay, so I have my GCF, and I have my terms. So when I divide 6 by 6, what do you get? So they cancel each other to 1. How about y cubed over y squared? Y. Again, I'm going to show you y. So y times y times y, that gives you y cubed over y times y. So they cancel each other. So you'll be left with y. Okay, can I write 1y or nothing, or just y? It's the same thing. Minus, what's 24 divided by 6? 4. And then the y squared and the y squared, they cancel each other, and that would be just 4.
So the reason why you're left with the y in the first one is because they exploded?
Yes. So you see how you have y to the power of 3 over y to the power of 2. Y to the power of 3 means y times y times y over y times y. So basically these cancels, and you're left with 1 y left. Okay? Are we okay with this? It's not bad. Okay. Let's look at this question right here. So factor 9x plus 3. That's an easy one. What would be your greatest common factor? 3. I can divide 9 by 3, and I can divide 3 by 3. Good. Is there any letter?
No.
Is there an x here?
No.
So there is no letter. X has to be in both terms. Okay? It is not in both terms, so there's no x. So my greatest common factor is 3, and I'm going to divide each term by 3. You see that? So what's 9x divided by 3? 3x. And what's 3 divided by 3? 1. That's it. So here's what I want you guys to do. I'm going to stop the recording right now. But I'll stay on with you, Stacy. So I want you guys to try this, 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 and this. Okay? So these are the support questions that I want you to try right now.